Fine, so here we can go with the second question of the Unit 2 worksheet, which is talking about motion of a ball falling in oil. And the first question was distinguish between average speed and instantaneous speed. So we know average speed is the distance traveled divided by a change in time, by the time taken. So it's over quite a large period of time. So your average speed, if we write it like this, you would need to write this out in full, is basically your distance divided by the time. Now your instantaneous speed is the speed in a given instant. So instantaneous and in an instant. So it's the speed at a specific instant. At a specific instant. Alright, good. Now in the B question here, a small steel ball of mass m is dropped from rest into a long vertical tube that contains oil. The sketch graph shows how the speed v of the ball varies with time t. So explain how you would use the graph to find the average speed of the ball between time t is equal to 0 and time t is equal to 1. So it's in this period over here from 0 to time t is equal to 1. Now, because we know that the average speed is equal to our distance over our time, we would need to know what the distance is, and from that we could get from the area underneath the curve. So this area here, if we found that area, it wouldn't be so easy because it's a curved line, but that area there would actually give us the distance. And so we would take that area, we would find the area, and then we'll divide by the time t1, and that would give us an average speed. Good. So let's go on to the next question here. So we're going down to C, and it says there the gradient of the graph at time t is equal to t1 is k. Deduce an expression in terms of k, m, and g, the acceleration of free fall for the magnitude of the frictional force F acting on the ball at time t is equal to t1. So we know that if that is equal to k, then your force, that's your resultant force that's acting on this, is actually going to equal k, because that would be the acceleration. The resultant force acting on that would equal to km, the acceleration. Now this resultant force here is actually going to be your mg minus your frictional force. That's the resultant force that we have. So we want to deduce an expression in terms of k, m, and g, the acceleration for the magnitude of the frictional force F. So we would therefore have that F is equal to, if we bring that over to the other side, take it over to the other side, is equal to mg minus km. So we would have g minus k times m would be a expression for the frictional force F. In D, it says state and explain the magnitude of the frictional force when the ball is at T2. Now, if we look at the graph, I can't actually see it here. Well, let me just bring it up and then we can have a look at it. We can close that and go up to it. At time t is equal to 0, you can notice here that your velocity is constant. There is acceleration is equal to 0, and therefore the force resultant, the resultant force or the net force acting on it is 0, and therefore we can say that the going back down there, that your frictional force must equal to the force due to gravity, the weight at that point. So the net force is acting on this is 0. Your force net is 0, so that mg minus F equals 0 newtons, and therefore there's a 0 force in F. By Newton's first and second laws, there will be 0 acceleration taking place. Fine, so that was question 2.